Hello and welcome back to Aerospace and Mechanical Lab 2. We are going to talk about Lab 9 today of the Aerospace and Mechanical Lab 2 course. Lab 9 is about fans, propellers, and the thrusters generate. We essentially have to calculate the thrust of a propeller, one of the propellers we have in here, using the equations that was provided to you in the lecture notes, and then measure the thrust using the thrust stand that we have right here. This is a very short lab. It's not going to take that much of time, which I guess can be a good grade after all of the computational labs and the full mini project that you have done so far. So the basics of the lab is pretty simple. We have a thrust stand that is connected to a computer. I'm using my own laptop right now, but the software I have on my own laptop is installed on all of the lab computers as well. You have to use the same software. And we have a power supply that is providing power to our thrust stand. And we have a USB-C that is bringing data to our software. Let's have a closer look to the thrust stand that we have here. This is our setup. We have the power supply, we have the thrust stand, and we have the my computer, my laptop, and software. Software is called RC Benchmark. It has a very intuitive GUI, but there's an order to setting this up. You want to make sure that this is connected to power supply first, and then connected to USB. The reason is USB itself can also provide power, but the power is not enough to run the thrust stand. So you want to make sure that you provide power first and then provide connect the USB to make sure that you have connection to your laptop and you can read the data off of the thrust stand. The power supply connection can be tricky. You can see there are two wires. One of the wires goes to the plus, to the positive port, and one of the other wire goes to the negative port. You want to make sure that these wires are connected correctly. How do we check that? It's pretty simple. If you connect them and this green light comes on, means that you have the correct connection. If it doesn't come on, you don't have the correct connection. Okay? Then when you connect the USB, you have to open this RC Benchmark software. Let me zoom in a little bit so you have a better view of the software. This is how the software is going to look like. Whenever your device is connected, you are going to see all of this information right here. The thrust calibration is done on all of these machines many times, but whenever you connect it to a new computer, this is the message you receive. You don't really need to do the thrust calibration unless whenever you're doing the experiments, you see a value other than 0 thrust when the device is not running. Okay, so when this is connected, you want to come to safety cutoffs right here. The first thing you want to do, you want to make sure that all of these values are set to the maximum range that is set here. Specifically this power one. The maximum power is 1400 watts. We never go to 1400 watts. We usually stay at a lot less than 1400 watts. I don't really remember the correct value off the top of my head. But we want to make sure that we have enough room to play with the machine. And then you want to go to manual control. You want to record RPM. You want to record thrust. You want to record ESC power. This is your engine power. You can record efficiency, but you don't need to. You have to calculate efficiency based on the data you record and based on the equation that is given to you. And you can check the continuous recording, which essentially means that it will keep recording the data, real-time data. So you have data versus time as well. Or you can just log a snapshot of your run. Okay, so to run the device, you want to make sure that you check this ESC. You hear this sound, it means that it is working. The system is working, and you want to slide this up. So this will start moving. It gives you the RPM of the motor. This is the motor rotation speed. This RPM can help you measure the linear velocity of the propellers itself. It does measure a thrust for us. Thrust is negative 0.02 kilograms of force, as you can see right here. The reason it's negative, it means that it's just we are pushing it in the opposite direction, this direction essentially. Because force is a vector, negative sign of the force means that it is in the opposite direction. We have the electrical power. Using thrust and electrical power and the propeller velocity, we can calculate the efficiency. That's for your efficiency calculation. And we also want to test the accuracy of the equation that we are using. So to do so, we need to calculate the velocity of the propeller, and we also need to calculate the velocity here after the fan. We are going to assume the velocity here is 0. This is a very good assumption because there is no flights. So, and this is the flow meter that we want to use. Just have to turn this on. 2 meters per second right here. And there are a couple of options. It asks you whether you want English units or metric units. And it also asks you whether you want real-time values for velocity or average 16-second values. We want to change this to average 16-second values. And there's nothing else you need to set. You just need to put this in front of the machine. And it will read the velocity for you. Just read the velocity. The velocity is going to come on this panel. Just read the velocity off of this and do the calculation for yourself, for your fan. You want to make sure you turn off this flow meter, because like this one was not turned off, as you can see, doesn't have any batteries. That's why we can't really read any values off of it right now. But you have to keep in mind that this is 16-second average as well. So you have to hold the flow meter here for at least 60 seconds. So one part of the lab is done now. The next part of the lab is to test a different propeller. So different groups can test different propellers and share the data with each other. By different propeller, we essentially mean just a different size propeller, or a propeller that uses different airfoil, or a propeller that has more than 3, or a fan that has more than 3 propellers. Very simple lab, easy to do, and you can finish the lab soon. Let me just turn this off and close the software, and that will be it for the fan truss and fans lab.